want to talk to you about the future of medicine. Before I do that, I want to talk a little bit about the past. Now, throughout much of the recent history of medicine, we've thought about illness and treatment in terms of a profoundly simple model. In fact, the model's so simple that you could summarize it in 6 words. Have disease, take pill, kill something. Now, the reason for the dominance of this model is, of course, the antibiotic revolution. Many of you might not know this, but we happen to be celebrating the 100th year of the introduction of the antibiotics into the United States. But what you do know is that that introduction was nothing short of transformative. Here you had a chemical, either from the natural world or artificially synthesized in the laboratory, and it would course through your body, it would find its target, lock into its target, a microbe or some part of a microbe, and then turn off a lock and a key with exquisite deftness, exquisite specificity, and you would end up taking a previously fatal, lethal disease, a pneumonia, syphilis, tuberculosis, and transforming that into a curable or treatable illness. You have a pneumonia, you take penicillin, you kill the microbe, and you cure the disease. So seductive was this idea, so potent, the metaphor of lock and key and killing something, that it really swept through biology. It was a transformation like no other. And we've really spent the last 100 years trying to replicate that model over and over again in non-infectious diseases, in chronic diseases like diabetes and hypertension and heart disease. And it's worked, but it's only worked partly. Let me show you. You know, if you take the entire universe of all chemical reactions in the human body, every chemical reaction that your body is capable of, most people think that that number is on the order of 1 million. Let's call it 1 million. And now you ask the question, what number or fraction of reactions can actually be targeted by the entire pharmacopoeia, all of medicinal chemistry? That number is 250. The rest is chemical darkness. In other words, 0.025% of all chemical reactions in your body are actually targetable by this lock and key mechanism. You know, if you think about human physiology as a vast global telephone network with interacting nodes and interacting pieces, then all of our medicinal chemistry is operating on one tiny corner at the edge, the outer edge of that network. It's like all of our pharmaceutical chemistry is a pole operator in Wichita, Kansas, who's tinkering with about 10 or 15 telephone lines. So what do we do about this idea? What if we reorganized this approach? In fact, it turns out that the natural world gives us a sense of how one might think about illness in a radically different way. Rather than disease, medicine, target, in fact, the natural world is organized hierarchically upwards, not downwards, but upwards. And we begin with a self-regulating, semi-autonomous unit called a cell. These self-regulating, semi-autonomous units give rise to self-regulating, semi-autonomous units called organs. And these organs coalesce to form things called humans. And these organisms ultimately live in environments which are partly self-regulating and partly semi-autonomous. What's nice about this scheme, this hierarchical scheme, building upwards rather than downwards, is that it allows us to think about illness as well in a somewhat different way. Take a disease like cancer. Since the 1950s, we've tried rather desperately to apply this lock and key model to cancer. We've tried to kill cells using a variety of chemotherapies or targeted therapies. And as most of us know, that's worked. It's worked for diseases like leukemia. It's worked for some forms of breast cancer. But eventually, we've run to the ceiling of that approach. And it's only in the last 10 years or so that we've begun to think about using the immune system, remembering that, in fact, the cancer cell doesn't grow in a vacuum and actually grows in a human organism. And could you use the organismal capacity, the fact that human beings have an immune system to attack cancers, in fact, led to some of the most spectacular new medicines in cancer. And finally, there's the level of the environment, isn't there? We don't think of cancer as sort of altering the environment. Let me give you an example of a profoundly carcinogenic environment. It's called a prison. You take loneliness, you take depression, you take confinement, and you add to that, rolled up in a little white sheet of paper, one of the most potent neurostimulants that we know, called nicotine, and you add to that one of the most potent addictive substances that you know, and you have a pro-carcinogenic environment. But you can have anti-carcinogenic environments too. There are attempts to create milieus, to change the hormonal milieu for breast cancer, for instance. We're trying to change the metabolic milieu for other forms of cancer. Or take another disease like depression. Again, working upwards. Since the 1960s and 1970s, we've tried, again, desperately, to turn off molecules that operate between nerve cells, serotonin, dopamine, and tried to cure depression that way, and that's worked, but then that's reached a limit. And we now know that what you really probably need to do is to change the physiology of the organ, the brain, rewire it, remodel it. And that, of course, we know study upon study has shown that talk therapy does exactly that. And study upon study has shown that talk therapy combined with medicines, pills, really is much more effective than either one alone. And can we imagine a more immersive environment that will change depression? Can you lock out the signals that elicit depression? Again, moving upwards along this sort of hierarchical chain of organization. What's really at stake, perhaps, here is not the medicine itself, but a metaphor. Rather than killing something, in the case of the great chronic degenerative diseases, kidney failure, diabetes, hypertension, osteoarthritis, maybe what we really need to do is change the metaphor to growing something. And that's the key, perhaps, to reframing our thinking about medicine. Now, this idea of changing, of creating a perceptual shift, as it were, came home to me to roost in a very, very personal manner about 10 years ago. About 10 years ago, I've been a runner most of my life. I went for a run, one Saturday morning run. I came back and woke up and I basically couldn't move. My right knee was swollen up, and you could hear that sort of ominous crunch of bone against bone. And one of the perks of being a physician is that you get to order your own MRIs. And I had an MRI the next week, and it looked like that. Essentially, the meniscus of cartilage that is between bone had been completely torn, and the bone itself had been shattered. Now, if you're looking at me and feeling sorry, let me tell you a few facts. If I was to take an MRI of every person in this audience, 60% of you would show signs of bone degeneration and cartilage degeneration like this. 85% of all women by the age of 70 would show moderate to severe cartilage degeneration. 50 to 60% of the men in this audience would also have such signs. So this is a very common disease. Well, the second perk of being a physician is that you can get to experiment on your own ailments. So about 10 years ago, we brought this process into the laboratory, and we began to do simple experiments, mechanically trying to fix this degeneration. We tried to inject chemicals into the knee spaces of animals to try to reverse cartilage degeneration. And to put a short summary on a very long and painful process, essentially it came to naught. Nothing happened. And then, about 7 years ago, we had a research student from Australia. Now, the nice thing about Australians is that they're habitually used to looking at the world upside down. And so Dan suggested to me, maybe it isn't a mechanical problem, maybe it isn't a chemical problem, maybe it's a stem cell problem. In other words, he had two hypotheses. Number one, there is such a thing as a skeletal stem cell that builds up the entire vertebrate skeleton, bone, cartilage, and the fibrous elements of skeleton, just like there's a stem cell in blood, just like there's a stem cell in the nervous system. And two, that maybe the degeneration or the dysfunction of this stem cell is what's causing osteochondroarthritis, a very common ailment. So really the question was, were we looking for a pill when we should have really been looking for a cell? So we switched our models, And now we began to look for skeletal stem cells. And to cut again a long story short, about 5 years ago, we found these cells. They live inside the skeleton. Here's a schematic and then a real photograph of one of them. The white stuff is bone, and these red columns that you see and the yellow cells are cells that have arisen from one single skeletal stem cell, columns of cartilage, columns of bone coming out of a single cell. These cells are fascinating. They have 4 properties. Number one is that they live where they're expected to live. They live just underneath the surface of the bone, underneath cartilage. You know, in biology, it's location, location, location. And they move into the appropriate areas and form bone and cartilage. That's one. Here's an interesting property. You can take them out of the vertebrate skeleton. You can culture them in petri dishes in the laboratory, and they are dying to form cartilage. Remember, we couldn't form cartilage for love or money? These cells are dying to form cartilage. They form their own furrows of cartilage around themselves. They're also, number 3, the most efficient repairers of fractures that we've ever encountered. This is a little bone, a mouse bone that we fractured, and then let it heal by itself. These stem cells have come in and repaired in yellow the bone and white the cartilage almost completely. So much so that if you label them with a fluorescent dye, you can see them like some kind of peculiar cellular glue coming into the area of a fracture, fixing it locally, and then stopping their work. Now, the 4th one is the most ominous, and that is that their numbers decline precipitously, 10-fold, 50-fold as you age. And so what had happened, really, is that we found ourselves in a perceptual shift. We had gone hunting for pills, but we ended up finding theories. And in some ways, we had hooked ourselves back onto this idea, cells, organisms, environments, because we were now thinking about bone stem cells, we were thinking about arthritis in terms of a cellular disease. And then the next question was, are there organs? Can you build this as an organ outside the body? Can you implant cartilage into areas of trauma? And perhaps most interestingly, can you ascend right up and create environments? You know that exercise remodels bone, but come on, none of us is going to exercise. So could you imagine ways of passively loading and unloading bone so that you can recreate or regenerate degenerating cartilage? And perhaps more interestingly, more importantly, the question is, can you apply this model more globally outside medicine? What's at stake, as I said before, is not killing something, but growing something. And it raises a series of, I think, some of the most interesting questions about how we think about medicine in the future. Could your medicine be a cell and not a pill? How would we grow these cells? What would we do to stop the malignant growth of these cells? We heard about the problems of unleashing growth. Would you have to implant suicide genes into these cells to stop them from growing? Could your medicine be an organ that's created outside the body and then implanted into the body? Could that stop some of the degeneration? What if that organ needed to have memory? In cases of diseases of the nervous system, some of those organs have memory. How could we implant those memories back in? Could we store these organs? Would each organ have to be developed for an individual human being and put back? And perhaps most puzzlingly, could your medicine be an environment? Could you patent an environment? You know, there's been, in every culture, shamans have been using environments as medicines. Could we imagine that for our future? I've talked a lot about models. I began this talk with models, so let me end with some thoughts about model building. That's what we do as scientists. You know, when an architect builds a model, he or she is trying to show you a world in miniature. But when a scientist is building a model, he or she is trying to show you the world in metaphor. He or she is trying to create a new way of seeing. The former is a scale shift, and the latter is a perceptual shift. Now, antibiotics created such a perceptual shift in our way of thinking about medicine that it really colored, distorted, very successfully, the way we've thought about medicine for the last 100 years. But we need new models to think about medicine in the future. That's what's at stake. You know, there's a popular trope out there that the reason we haven't had the transformative impact on the treatment of illness is because we don't have powerful enough drugs. And that's partly true. But perhaps the real reason is that we don't have powerful enough ways of thinking about medicines. It's certainly true that it would be lovely to have new medicines, but perhaps what's really at stake are three more intangible M's: mechanisms, models, metaphors. Thank you.
So I mean, I really like this metaphor. How does it link in? There's a lot of talk in technology land about the personalization of medicine, that we have all this data and that medical treatments of the future will be for you specifically, your genome, your current context. Does that apply to this model you've got here?
It's a very interesting question. You know, we've thought about personalization of medicine very much in terms of genomics. That's because the gene is such a dominant metaphor, again, to use that same word, in medicine today, that we think of, you know, the genome will drive the personalization of medicine. But of course, the genome is just the bottom of a long chain of being, as it were. That chain of being, really, the first organized unit of that is the cell. So if we are really going to deliver medicine in this way, we have to think of personalizing cellular therapies, and then personalizing organ or organismal therapies, and ultimately personalizing immersion therapies for the environment. So I think at every stage, you know, they say that, there's that metaphor, you know, that turtles all the way. Well, in this, there's personalization all the way.
So when you say medicine could be a cell and not a pill, I mean, you're talking about potentially your own cells.
Yeah, absolutely.
So converted to stem cells, perhaps tested against all kinds of drugs or something, and prepared.
And there's no perhaps. This is what we're doing. This is what's happening. And in fact, we're slowly moving not away from genomics, but incorporating genomics into what would be called multi-order, semi-autonomous, self-regulating systems, like cells, like organs, like environments.
Thank you so much.
Pleasure.
That was cool.